Alright, good morning. Apologize, a little late to the party there. Who is not muted? Alright, let me just get a new page here, and we'll be good to go. Today we are talking about percentages. Percentages give a very nice topic that is a continuation of fractions. At the same time, it is pretty practically relevant. You see percentages everywhere, so having some knowledge about them, how they work in the calculations, can only be beneficial. And it also helps us cross over to the next and last chapter. So, let me get set up here with my pen. We're good to go. Alright, so let's write here. Percentages. Now, people see percentages in a variety of ways that I can't always predict, but it's really quite simple. I can have many different fractions, right? Many kinds of fractions and proportions, because the denominator can be so many different things. For example, 2/5, 3/4, a half, all those, so many, even simple fractions, still quite a variety. And it's difficult to very quickly compare these fractions to each other, especially when they're close. If I think, well, let's make another one here. 2/5 versus, I don't know, let's say 5/11. The bigger the denominator, the more difficult it could be to very quickly just compare them and know which one's bigger, how do they compare, if it's maybe a discount on an item in a store, which one's a better discount. It became very obvious that leaving the fractions to have any denominator isn't quite as convenient for the public as it can be. So they said, let's just standardize all of these and make the denominator 100. 100 because we have a decimal number system, powers of 10. 100 is a power of 10. So it's maybe an obvious choice. 100 is the denominator. Now, in some cases, with a convenient fraction, that is easy enough to do by just multiplying by the same number on both sides, sort of reversing the simplification process. I would have to have 5 times 20, and then I would have to do it at the top as well. So that would give me 40 out of 100. And then we will call that 40%. Now, where this percentage symbol comes from is exactly the 100 of the 100. And that's now our percentage symbol, indicating that we are always going to have a fraction with a denominator 100. Why write the full fraction? We're only concerned with the numerator because that's the only thing that could possibly be different if the fraction is standardized to have denominator 100. So we only reference the numerator, and then we say, well, it's a percentage, meaning it's a fraction over 100. This one, let's see if I can squeeze it in here. We would have to go times 25, so I'd have to go at the top as well, and that would give me 75 over 100. 75%. So, not too difficult in cases where I have a nice common factor to find. This one over here will be 50 over 100, obviously. Let's just write it over here, and that'll be 50%. But of course, you see that, okay, some fractions might not be as convenient. So let's just find another way to get to this percentage value, when I don't really care about the fraction in its full original version. I only care about the numerator. So if you take 2/5, I can take 2/5, or I can take its equivalent 40 over 100. And how can I just get the 40? I can multiply by 100. That would cancel the denominator, which I don't care if it's there, and give me 40. Now, many people put 100 over 1 to emphasize a top and a bottom can cancel. Great. Then I get my 40. And then I just put the percentage sign behind it to say what I'm trying to say. So perhaps people do this anyway. Though it doesn't really have a unit at this stage. I'm free to do with it whatever I want. So technically speaking, in a sentence, you can then do with this 40 whatever you want. So the fractions here are the same, so I'm going to multiply by 100 here as well. And then I get 200 over 5, and that's also 40. So it doesn't matter which version. If I multiply by 100, out comes the percentage value. I can do that for 3/4 times 100 is going to be 75. 1/2 times 100, obviously 50. So I don't have to think about the full fraction over 100. The 100 is standard. I'm just looking for the denominator. So I can take my original fraction, multiply by 100, and out comes the relevant part of the percentage value. So I can also do that for fractions that are a little less convenient. 5 over 11. Multiply that by 100, and out comes the percentage value that I'm looking for. Let's do that in MathBot to see it. So I have 5 divided by 11 times 100. And we get 45.45. Repeating, I'll just round it to 2 decimal places. So now it becomes a little bit more efficient, that I don't have to think about the fraction standardized over 100. I'm just looking for the percentage, but understanding that this percentage is still a portion of something. It is still a fraction, just in disguise, capturing only the important aspect of that fraction. So let's see if we have some examples to work with. Percentages over here. Okay, so we have exercise 15.1. Now, I already did 3/4, didn't I? Well, I'll do it anyway. Now I lost it. There it is. Okay. Just to be official, exercise 15.1, just warm-up exercises. 3/4 times 100. I know that's 75. So 3/4, 75%, same thing. For 1 1/5, I'm now a little bit past the complete left intuitive side of things. So that's where mixed numbers sit. Anything a little bit more efficient, a little bit more calculation oriented, mixed numbers don't really work. It's a presentation option. So I'm going to go improper fraction, and then I'll multiply by 100. Maybe I don't know what that is. I don't have to. Calculator is totally fine. Let's do it. 6 divided by 5 times 100. Random line. And we get 120. So 120% is the same as 1 1/5, 6 over 5, whichever version you want. But in calculations, don't ever use mixed numbers unless my, I guess, quote-unquote calculation is a very simple rectangle style. Anything past that, mixed numbers have no place. It's a presentation. It's a basic intuitive style of fraction. Okay, so going from a fraction, standardizing it to a percentage shouldn't be a problem. Then we have the other. Actually, no, it's not really the other side. It's still the same side. 15.2. Let's suppose you have a test and you score some scores. Of course, the total of the test could vary. What's your percentage on the test? How can that not be a relevant question? Super relevant. I can't think of anything more relevant. Or you see on the website the percentages are listed, yet your quiz paper came back with a score. Is it the correct percentage? Does it match? Was there a mistake on the spreadsheet? You need to check these things. It's important. So 25 out of 30, that'll correspond to a fraction 25 over 30. I multiply that by 100. I get a percentage. It's as simple as that. Let's do it. And we get 83.33. I round to 2 decimal places because it's not nothing, but it's not too much. So you scored a nice 83-ish%. Very nice. But the next quiz maybe didn't go so well. Or maybe it did. It's really hard to say. Is 16 out of 22 good? Well, it depends on what you want it, right? 16 over 22 times 100. I don't know what that is. That's why we have calculators. 16 over 22 times 100 to know precisely 72.73%. I just round automatically because it's my final answer. I'm not using it in any future calculations, so it's perfectly safe to do the rounding. So 72 is not bad. I'll take it. And the last one, we got, for some reason, there was a ton of bonus questions. And we got 45 out of a possible 30. Bonus questions, yeah. Still make my fraction. Times by 100. I should get 150%, right? It's a very strange test, but let's take it. I'm not going to say no. 150%? Okay, I'll take it. So it really is that straightforward when I'm converting between fractions and percentages. Percentages are just a more digestible fraction. People don't like fractions? No, here's a percentage. But it's actually the same thing. But we don't view them as the same. They're standardized. They don't look like fractions. But they are. It's exactly the same thing. All right. So now, when we want to move over to some interesting problems, something a little bit more practical, involving percentages, we have to be able to do calculations with percentages. And there are 3 main percentage calculations that I have to be comfortable with first, before I can put a word problem layer on top. I have to be comfortable with how to use calculations involving percentages. Okay, so there are three kinds of calculations we need to go through. Some of them are similar, some of them are not. And these are the only ones that can really come up. Nothing else can really come up. First kind of calculation is taking a percentage of a quantity or number. Quantity. Let's suppose I had Halloween candy, but I wanted to keep some for myself. I wanted to keep 25% for myself, and the other 75% I'll hand out during Halloween. So I have some quantity, and I want to take a percentage of that to keep to myself, for example. For example, let's say I want to take 25% of how much candy do I have? Let's make it 150 pieces of candy. Pieces of candy. How much do I need to count and keep for myself? So remember, this percentage is a fraction. It's 25 over 100. 150, 150. Of, in terms of calculation purposes, is multiplication. And there is my calculation. 25 divided by 100 times 150. And I can calculate that. Sometimes it's straightforward, sometimes it's not. Let's do it either way to see something in the chat. That is not what I wanted to do. Oh, now my Discord chat zoomed in a whole bunch. How do I get rid of that? Okay, I think I got rid of it. Yeah, I think we're good. 25 divided by 100 times 150 is 37.5. Remember, this answer now is pieces of candy. So I have to decide, do I do 37 or do I do 38? Or do I just cut a piece of candy in half and then give some random kid a half a piece? That might not be the best idea. Regardless, I need to take a percentage of some quantity. That is multiplication. Now, when you look at your calculator, you might see a percentage button. Could be second function, could be randomly placed. It depends on your calculator, of course. My recommendation is to never ever touch that button. Never use that button. Ever, ever. Just put a little sticker over it. It doesn't exist. Make the fraction that corresponds to the percentage. It's not hard. You just divide by 100 and then multiply and apply that to your quantity. Some people are taught to say 25 times 150 and then press the percentage button. The problem is you don't really know what that button does. In some cases, the calculator makes it fairly obvious that it's doing the division by 100. In some cases, it really depends on when you press that button. And it feels like a very mysterious button to me. And if I don't know what it's doing exactly from one calculator to the next, it's better to just type in the calculation. The extra divided by 100 is not a lot of work, and then you know exactly your calculation. You might not know what I'm talking about, but I've seen it. It can create some confusion because not all calculators work that button the same way. Just be aware of that. I would never touch that button. Calculation is not hard. That's pretty much it. You multiply by the quantity, and you multiply the fraction version of the percentage. Let me just see if I have any examples I want to do. So here I have 25% of a quantity. Let's keep that quantity open. Then it's just, excuse me, the fraction version times the quantity. Is there more? Oh, okay, so there is a little bit of an exercise for us to practice. But it's the first type of calculation for a reason. It's not overly difficult. That said, we all have different backgrounds, different experiences. Some of us have thought about and worked with percentages before. Some of us may never have really given it much thought. We want to get everyone up to speed. So if this is super easy for you, great. If it's not, I am not wasting your time. Whoopsie. See how I do the multiplication already? It's bad. I'm so used to of meaning multiplication. There we go. That's my question. I need to take 75% of 60, whatever that 60 may be. My calculation is then 75 over 100 times 60. Calculate that. It's probably as easy as it gets with a calculator. 75 divided by 100 times 60. Get rid of that line. And it's 45 pieces of candy or whatever unit I'm working in with this 60. I would, again, strongly encourage you to not ever say something like this. A percentage is a presentation thing. It's for presentation purposes only. It should not be in a calculation. It's the presentation of over 100. If you want to have a calculation, you use the fraction, or you use the over 100 as it technically should be, not presentation. Just like I wouldn't, past the intuitive level, I wouldn't use mixed numbers in a calculation either. They're presentation things. Now you could go and say here, maybe I don't love fractions. I know everyone does love fractions, but let's just suppose you don't want to see the fraction every time. I could go decimal. Because it's always over 100, the decimal version of this fraction is super easy. It's 0.75. And then times that by 60. And of course, I'll still get 45. I want to actually be okay with either one of these. I want to be able to flip back and forth. Decimal version, fraction version, they're the same thing. It's equivalent. It's equivalent. But if you don't love the look of fractions, you feel it's a lot of work to write the line and then the 100. Whew, that's 4 different things I have to write down. You can save some time by going the decimal route instead. Okay, so I want to be okay with either one of these. This was number 1. Again, we start off nice and slow so that I build a good understanding of percentages in this first kind of calculation. Take a percentage of a number. Later on, especially when we put the word problem layer on top, it's not going to be that simple. And I'm going to build on, I'm going to use these basics. So they need to be solid. Plus, I am in no rush whatsoever. 30% of 27 something, $27, 27 pieces of candy, whatever. Notice here that this is the word of, not off, with 2 F's. That's a completely different thing. So if language isn't your thing, please pay attention to the word we're using here. I'm taking a percentage of a number, a portion of some quantity. So the calculation in whatever version you want, 30 over 100 of is multiplication, and 27 is my number. Get an answer, or you can say the decimal version is 0.30 if you want, times 27. Let's do the decimal version here for the calculator. No, that's not it. No, I forgot my point. 3 times 27. I could have adjusted it, but that's better to show in chat exactly the answer. course, these are exactly the same. 8.1 pieces is what I get. All right. Use either version. Use both. Be happy with either one. Don't neglect the decimal one. It is more efficient when we move forward. So I definitely want to be okay with the decimal version. And lastly, the nice thing here about percentages is the meaning of the of doesn't actually change, like multiplication in general had a couple of interpretations depending on the size of the first fraction. Here, it doesn't even matter. I'm taking a percentage of a quantity, whether you want decimal version, fraction version, it's multiplication regardless. So let's see what the answer is there. I can, for some reason, take 120% of a quantity, whatever the practical motivation is for that. I'm going to end up with more than what I had, because the fraction is an improper fraction, or it's a mixed number, if you will. It's more than 1. What do I end up with? I forgot to actually calculate that. Let us see. Nope, my equal signs. Equal. 1.2 times 14. 16.8. 16.8. So definitely in terms of calculator button presses, definitely the decimal one is a little faster. So it might be one that you are leaning towards, and that's a good thing. But don't forget where the percentage comes from. It comes from the fraction. All right. So that's our first one. Taking a percentage of a quantity, could be a large percentage, could be a small percentage, really doesn't matter, doesn't affect the calculation. So that's a good thing. But do notice that if it's a percentage larger than 100, I'm going to get more than the original quantity. So I have this baseline. If it's below 100, then I get less. If it's above 100%, then I'm going to get, for some reason, more than the quantity. It's important to realize that. Okay, so next up, number 2, is to increase a quantity by a percentage. Squiggly lines. Increase a quantity by a percentage, for example. Now, for me here, intuitively, it feels better to talk about dollar amounts. Just for me, it feels good. Pretending I have money that increases. So let's suppose I increase, let's make it $2,000 by, let's go 15%. For some reason, whether it's from the bank or wherever, I have the opportunity to increase $2,000 by a certain percentage, 15 in this case. Now, what is really happening here? When I break it down to a level that I have seen before, I have my new amount calculated as my original $2,000. I'm going to squeeze it. I can't quite squeeze it in there. Plus, I'll put it in brackets, 15% of $2,000. So increasing means I have my original. It's not going to change. On top of that, I get 15%. How much do I have in the end? Well, of course, I have my original plus this increased amount. So I have two separate things that I merge together. So I have 2,000 plus, now I have to figure out this, but this in the second bracket here is exactly a percentage of a quantity. And I've seen that before. I've seen it here. So that is simply going to be percentage version of 15%, 0.15 of is times 2,000. I'll put these in brackets to illustrate that this comes first, of course. This is a grouping. Then it gets merged with the original. So now I'll just elaborate here, not to try and confuse you, but to be as detailed as possible. I have one of my original 2,000. I get another 0.15 of 2,000. How many 2,000s do I have? 1.15. If you want to see it in a different way, I factor out the 2,000, 1 plus 0.15. So in here, in this factor that is applied to the 2,000 stated originally is 1 plus 0.15. The 1 is referring to my original amount that I keep. I don't lose the original 2,000. The 0.15 is the decimal version of the percentage in question. And because I'm increasing, I'm getting that on top of my original. I am adding. Adding because of an increase that I get. So really it's all about calculating this factor, I'll call it. I'm going to go above 1. 1 refers to 100%, refers to my original, my base. I'm going to go above that by how much? Well, the percentage that I'm increasing tells me how much. I just make it a decimal, the decimal version. Okay. So this is going to be the efficient calculation. If I want to understand where is this coming from, yes, I break it up. New amount, original plus percentage of that amount, blah, 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 blah. But when I actually just want to implement it, get the calculation, this decimal version is what I want to construct. Think of it as constructing this decimal adjustment of the amount. So let's see some exercises here. We have some discussion. Okay, I'm going to make my own. We're not ready for the word problem necessarily. Because with word problems, there's a lot of variety that comes on top of this. And I might not be ready, so I'll make my own. Let's suppose we increase, let's say you have a lot of money, $12,000. And let's suppose you get 5%. Then my new amount is the decimal version, the decimal number I have to construct, of course, applied to 12,000. What is this decimal number? It's 1 point something, because I'm going to go up from my base 12,000. On top of that, I get 5%. What is the decimal version of 5%? 0.05. Let's get rid of that dot. That's just a habit. And then I can calculate that. I didn't even calculate the first one, did I? It wasn't important. 1.05 times 12,000. Random line. 12,600 is what I get. So my new amount here, something. Oops, 6. It's the calculation. The answer is a formality with a calculator. It's not important. Well, I mean, it is important, but it's a byproduct of the calculation. Just like all the other problems, we've said this before, people obsess about the answer when I obsess about the method. And in this case, it's the calculation. If I can set up the calculation, the answer is going to come out. I never have to worry about the answer. It's the calculation, the interpretation of these words into my mathematical language. All right, let's do one more. Sometimes people get a little confused when I increase by a very large percentage. And maybe we're not quite ready for that. Maybe we are. We'll see. Let's suppose we increase $1,000. Let's keep it nice and simple. By 250%. Maybe not 2. Let's make it a 1. Let's make it even simpler because I don't want to confuse people. Let's just make it 100%. And we'll make the 50 in a second. Let's do it like this. Now, we might have an intuition about 100%. That's double, isn't it? I increase something by 100%. I get 100% of that on top of what I had, which means I get all of it again. You would be right. My new amount is some adjustment factor applied to the 1,000. The look of this calculation doesn't change. What is this decimal number? Well, I'm increasing from my base, so I know I'm going to get 1 plus something else. The decimal version of 100%. So this is my original. I'm trying to write some stuff so that you can look back and make sense. I'm increasing, so the plus. I'm going to have the decimal version of the percentage. In this case, it happens to be 100%. That's also a 1, or 1.00 if you will. So my decimal factor is 2. 2.00 if you will, which confirms my suspicion that I'm doubling what I get. I'm not taking 100% of my number. It's an increase. It's a different calculation, different instructions. Increase some amount by a percentage. It's always the decimal version of that percentage on top of my base 1. Always. It's never going to change with this kind of calculation. Again, it depends on your experiences. Might be, actually I wanted to do 150, right? Might be, this might be very familiar, or it might be a little strange. Regardless, you're not wasting your time by being super comfortable with these kinds of calculations. Oh, not a lot of space. If I now change this to what I wanted originally, 150, what changes? Very little. The decimal version of the percentage is now 1.5. Sorry, it looks like there's a little thing extra here, 1.5. And therefore, when I put that with the 1, I get 2.5. Obviously, the calculation answer will change to 2,500. But the construction of the calculation, that is the key. It doesn't change. It doesn't change. All right. Last one is very similar to the second one. But sadly, what goes up probably comes down. So I have a decrease. Decreasing an amount. Of course, it doesn't have to be money, but that is usually what happens. Decreasing an amount by a percentage. Squiggly lines. This is my last one. There are no more. Any word problem I'm going to encounter ever is going to be some mix or something involving these three. So for example, let's do it the same way we did the increase one. Let's decrease $2,000. Decrease $2,000 by 15% for whatever reason. So now it's very similar. It's not the same. My new amount is going to be the original $2,000. Take away 15% of $2,000. Decreasing. I'm losing some money. So I have my 2,000 minus a percentage of a number. Decimal version times number. Because that's the first kind of calculation again. Now, I'll emphasize here, I have one of these 2,000s. I lose 0.15 of these 2,000s. Now, how many 2,000s do I have? I have 0.85 of 2,000s. I have 0.85 2,000s. Or you factor out the 2,000 and then you have 1 minus 0.15. So here is my adjustment factor, whatever you want to call it. It again comes from three things. It comes from an adjustment of my base amount, 1, or 1.00, or 100%, or whatever, from the original that is being adjusted, minus, because of the decrease, and then 0.15 because of that being the decimal version of the percentage in question. So instead of the increasing going up from the base 1, decreasing is going to go down from the base 1 and adjust it in the same way, just with a different factor. So it's very similar. And again, this is what I focus on. Construct the calculation. Construct this adjustment factor. Then the answer comes out of that. I don't actually ever think about the answer. Now you could do it by separating the original from the change amount. And in some cases, yeah, sure. But often that is going to create more work, and sometimes it's just not efficient at all. Having a compact, efficient calculation will always be a little bit better in the long run. Let's do some calculations. And tomorrow we'll worry about the word problem layer on top. I need these three calculations to be solid first before worrying about more complexity. So let's see some examples. Let's decrease that 12,000 that we had by 5%. My new amount. So here you can think, just to cover the possibility that someone might think like that, you might read this as, oh, take 5% off my 12,000. Totally fine. Still implies a decrease. That is not the first kind of calculation, right? Of taken percentage of. Just the case, because I knew there are some people, language is not necessarily your friend, different. So I try and not use the OFF to decrease, to have it be standing on its own a little bit more. But just be aware of that. I don't want that to be misread in a test. My new amount is sum adjustment of 12,000. Notice how I do a multiplication sign when I say the word of? That's not going to change. Yet I've seen kids that I work with that their teacher never told them that the multiplication sign is connected to the word of. Never. No one ever told them that. But then once they realize that, oh, word problems become so much easier. Well, I can't fix all the teachers, unfortunately. What is my scale adjustment factor here? I'm going to go, I'll write it down in detail here. My base 1, take away the decimal version of the percentage, and therefore it's 0.95. Because I decrease, I go down. And then the calculation is what it is. I honestly don't really care about it. I guess I should care, but it's a immediate consequence once my work is done. 0.95 times 12,000 is whatever it is. In this case, 11,400. So my new amount, 11,400. Now, when we do a full word problem, we'll have a concluding sentence and everything nicely. I'm just practicing right now. Let's quickly squeeze in one more. Why not? Now, people might feel a little uncomfortable when I decrease an amount by a large percentage. Let's go 85, though it can happen. My new amount, nothing changes. Sum adjustment of $1,000. What is that adjustment? It's my base 1, take away the decimal version of the percentage in question. So I have very little, unfortunately, left. Only going to be $150. So my new amount, maybe it was a very speculative investment, who knows. So it can happen. It's not as common. Small adjustments are more common, but it can definitely happen. All right. So lots to think about, perhaps. Please do think about it. Think about it as much as you need to, because everything we're doing in the future, percentage-wise, relies on one or a combination of these 3 calculations. So they need to be solid. Any questions at this stage before we pause here and pick it up tomorrow with the word problems? Nope. All right, then until tomorrow.
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.